Okay, beginning with 135, it says to examine the function graphed at right, which there's been a lot of occasions where I've wanted to review things at the end of class and it just hasn't happened. But I want to make sure that everybody knows how to tell whether or not a graph is a function. So you may have learned the vertical line test in the past. But the definition of a function is in the math notes from our very first lesson. And it says a relationship between inputs and outputs is a function if there is exactly one output for each input. Functions are often written as y equals something, where x is the input and y is the output. So here is a function. So in Math 1, I'm not sure if you had the soda machine problem. So if I punch -2, if I put -2 in the soda machine, if I put Coke in the machine, I get a Coke. If I put -2 in, I get 16. If I put -1 in, I get 9. Pepsi, I get a Pepsi. If I press Sprite, I get a Sprite. For each input, I'm getting exactly one output. If there was a case where I press Sprite and I not only get a Sprite, but I also get an orange drink, then that would not be a function. So that's why the vertical line test works. And you can draw a vertical line anywhere on the graph, and if it only crosses that graph once, that means it's a function. So I could draw a vertical line anywhere on this graph and it's only crossing the line once, that means yes, it is a function. For this input, there's exactly one output. For 1, the output is 0. It's not 1, 0, and 1, -3. And then over here, 4 for the input has an output of 3. That's the only output. So it's important to know what a function is. Okay, I'll stop there because it's a long assignment. Okay, then it says which x values have points on the graph. That is, describe the domain of G. So your domain, and I'm referring to these math notes because they have been grouped all together in your ebook so that you can find them quickly. So a domain is all your possible inputs. Anything that can give you an answer for that particular equation is part of the domain. So 135, there's several ways you can write the answer for domain. Let's get situated here. So all of the x values are between -2 and +4. There's no x values past -2. There's nothing past +4. So you could write that and I'm going to put half an equal sign here, half an equal sign here because there is an answer at -2. It's not an open circle. If it was an open circle, I would put x is greater than -2. And if there were an open circle at 4, less than 4. But because there are two closed circles there, I'm putting less than or equal to, greater than or equal to. You could also write that with brackets. You could also write it in words. And whatever makes the most sense to you, go with it. Okay, what are the possible outputs for g of x? So the range, those are all your outputs. So if you look at this graph, you've got a low point right here at, what is that, -2 and -1. And then your highest point is right here at 4, 3. So then our range is from -1 to +3. So y is between -1 and +3, and it's including those numbers. Just like if I was looking at it from the x perspective, -2 was included in the domain. If I'm looking at it from the perspective of the y-axis, -1 is an output. Okay, you could do this, or oh, I forgot to write and including. Okay, part C, Ricky thinks the range of G is -1, 0, 1, 2, and 3. Is he correct? So you might be thinking, sure, the range goes from -1 up to +3. But doesn't it include all of the numbers between -1 and 0, between 0 and 1, between 1 and 2, between 2 and 3? So he's actually incorrect because he's missing all of those numbers. And I should have here all real numbers. So we should put for part C, okay, that's one way of saying it. He should be including all of the numbers between those integers because the graph is continuous. If it was discrete, then he would be correct. If it was just those points and not the continuous line, then that would be correct. Okay, sketch the graph of another function with the same domain and range as G. So let me grab some graph. Okay, so my domain was -2 to 4, and my range was -1 to 3. So I'm just going to quickly do an x and y axis, making sure that those values are included in my graph. And let's see, -2 to 4, and then -1 to 3. So it's going to fit in that window, and it does say it has to be a function. So I couldn't do something like a circle. A circle would not be a function. Whoops, sorry. Circle or anything where you have one input having two outputs would not work. We could do a parabola. We could do a line. How about let's make it simple. We've got the point -2. -1, and we've got the point 4, 3. Let's just do a line in between those 2 points. Okay, there's part D. 136, George was solving the equation 2x minus 1 times x plus 3 equals 4, and he got the solutions x equals 1/2 and x equals 3. Jeffrey came along and said, you made a big mistake. You set each factor equal to 0, but it's not equal to 0. It's equal to 4. So you have to set each factor equal to 4 and then solve. Who is correct? And I'm just realizing I'm going to throw some announcements in here for homework. Make sure you are listening to the video, not just fast forwarding and blindly copying a math problem. Also, I'm showing you the problem in the book, but that doesn't mean that you're getting a chance to think about it. So I recommend that you have the ebook open to the homework assignment as you do the work. Look at the original problem and read it carefully. So you might want to pause the video or even try the work without the video and just use the video as a way to check. Don't just blindly copy math and think that that's going to help you grow. Also, draw all diagrams. If I draw it in my notebook, I expect you to have it. If I do it on graph paper, I expect you to do it on graph paper. Okay, so what's his name? Jeffrey says you have to set each factor equal to 4 and solve. Who's correct? Show George and Jeffrey how to solve this equation and be sure that you're correct. Check your solutions. Okay, so normally when we are solving a quadratic, we set y equal to 0 because we know that when it hits that x-axis, the x-intercept is going to have a y coordinate of 0. So in a way, he's right. Usually you have a 0 here. But he's saying your 2x minus 1 equals 4 and x plus 3 equals 4. This is not saying that each of these factors is 4. It's saying that the product of these factors is 4. So we need to back up and we need to set it equal to 0 to begin with. So let me write. Okay, so I'm going to quickly multiply 2x minus 1 times x plus 3. It's going to give me 2x squared combine like terms plus 5x. Oops. Minus 3 equals 4, and I'm just going to move this 4 over to the other side so that it is set equal to 0. And then I'm going to factor it. So remember, when you are solving in a quadratic, whenever that graph crosses the x-axis, any point on the x-axis is going to have a y coordinate of 0. So we always replace that y with 0. That's why I'm putting a 0 here, why I'm setting it equal to 0. Okay, so let's try factoring. Two x squared plus 5x minus 7. So we put our 2x squared and our negative 7 in opposite corners. And then we use our diamond to multiply these two, giving us negative 14x squared. And the two terms that we pick should add up to 5x. Well, what could we multiply to get a negative 14, but when we 14x squared, but when we add it, we get positive 5x. Right? 7x times 2x is going to give me 14x squared. I want the 7 to be positive so that when I add them, I get positive 5. So 7x and 2x are my missing terms, negative 2x. Okay, so let's see. We've got a common factor of 2x on this row. 2x times negative 1 would give me negative 2x, and then x times 7 would be 7x. So then this would be 2, x minus 1, and 2x plus 7. Then we're going to use zero product property, which this other person was kind of getting confused, I think. He was saying that just because these two products equal, or these two factors multiply give me 4, that this factor equals 4 and this factor equals 4. But that's not the case. The product of those two equals 4. The product of these two factors equals 0. That means 0 is special. If I'm multiplying two numbers and I'm getting 0, Either this factor is 0 or this factor is 0. Doesn't work for all numbers. So then x equals 1 or x equals negative 3.5. All right, let's move on to, hopefully that was a nice little refresh your memory type problem. By the way, you should be pretty good at doing that entire process that we just did. If you are not, let's find some time, I don't know, maybe after school, Saturday morning, whatever we need to do. You have to be up to speed on this process. Okay, and I will help you get there if you're not. Okay, for 137, on many graphing calculators, equations must be entered in the y equals form. Rewrite each equation in y equals form. Okay, so we're just getting y by itself. Okay, so let's isolate y. Divide both sides by 3. So y equals x minus 6 over 3. Okay, let's get y by itself. Add 10 to both sides. And then just divide by 5. Oops. All right. What do we have next? We have a quadratic. So we want to get y by itself. What's the opposite of squaring? Taking the square root. Okay. And we should put a plus or minus in front of that because it could be the positive root of x or the negative root of x. Okay, another quadratic. Let's add 4 to both sides. Divide both sides by 2. So x plus 4 over 2 equals y squared. Then we're going to do the same thing we did over here. Let's take the square root. So my final answer is plus or minus x plus 4 over 2. Square root of y squared is y. Oops. Let's move this up a little. I'm trying to drink my tea at the same time. Okay, let's get y by itself by going from the outside to the inside. So we're going to kind of like doing this in a different color. So the square root of x equals y minus 5, and that's really plus or minus square root of x equals y minus 5, and then just add 5 to both sides. So I'm going to put that 5 in front. So 5 plus or minus square root of x. All right. Pause for a second. All right, looking at 138, we have f of x equals 2x minus 7. And it says to compute f of 0, so we're just going to substitute 0 in the place of x. So that would give me 0 minus 7 is negative 7. Then it says solve f of x equals 0. So I'm setting f of x equal to 0. So 0 equals 2x minus 7. So then add 7 to both sides, divide by 2, There's your x-intercept. And then what do the answers to A and B tell you about the graph of y equals f of x? Well, I know that the value at 0 is -7. It has this point, and the value at 7/2, 3.5, is 0. So my y-intercept is 0, -7, and my x-intercept is 7/2. All right, 139. Jill needs to cut a smaller piece from a 30-foot length of lumber. Create multiple representations, table, graph, equation for the function with x values that are the length of the piece Jill cuts off and y values that are the length of the piece that is left over. Which representation best portrays the situation? So if she cuts off a piece that is 1 foot, she gets a 29-foot length. If she cuts off a piece that's 2 feet, she's at 28. So we're just going to make a table and a graph. Might just do a sketch. I'll say let's skip the graph paper and do a few key points on here. So she is, let's do the table. So x and y. So this is the length that's cut off, and this is the remaining length. So if she cuts off a piece that is, I'm going to leave a space for 0 just because we're going to want a y-intercept. If she doesn't cut anything off, she's got 30 feet. If she cuts off a piece that's 1 foot, she's got a 29-foot piece of, and so on, and so on, and so on, and so on. So if she, why don't we just do a few points, maybe, well, this doesn't make sense in real life, but we're going to want that x-intercept. So there's our table. Let's just do a sketch. Okay, 0 is 30. And 30 is 0. The slope is 1. Okay, there we go. 1-40, sketch a graph showing the relationship between the number of people on your school's campus and the time of day. So this is assuming we are in school. So in a normal situation, whoops, as the time of the day goes on, you go from having no one at the school to having a few people. And then all of a sudden, everyone's at school, mostly at the same time, right? And then people are staying at school. Maybe some people come late, so the amount gets larger. Maybe it gets to a high point, and then school gets out and everybody goes home. Maybe you have a few people staying for after-school activities. There you go. So you could do something like this. All right. Where is the error in this solution? Explain what the error is, solve the equation correctly, and check your answer. So let's see. 5 over x equals x minus 4. and this person, multiply both sides by x. Okay, so let's write what we would do. Would we have done the same thing? Okay, so the person says they're going to multiply both sides by x. Get rid of that fraction. Good idea. That's going to cancel out the x's on this side and leave you with 5. On the right side, if you're multiplying the left side by x, you have to multiply the right side by x. And this person did not do that. So there's the mistake right there. So it should be x squared minus 4x over here. And if we were going to solve this, we would set y equal to 0. So this is y equals x squared minus 4x. So I'm going to put, I want this to be 0, so I'm going to move this 5 over to the other side. That's going to give me 0 equals x squared minus 4x minus 5. And if I solve that, I need to factor. So x squared and negative 5 in opposite corners. Multiply those, that's going to give you negative 5x squared with a sum of negative 4x. So I'm looking for two numbers, the product of which is negative 5, the sum is negative 4. Okay, what can I multiply to get x squared? X times 1 is x, x times negative 5 is 5x. So that's going to give me x plus 1 times x minus 5, and I'm going to set that equal to 0. So that's going to give me, with 0 product property, x plus 1 equals 0, or x minus 5 equals 0. If I solve for x, that gives me x equals negative 1 and x equals 5. Those are your x-intercepts. Okay, create a table and a graph for g of x equals 2 over x, then completely describe the graph. Okay, I know this is a long assignment, so if you need to take a little break, come back to it. That might be a plan. This is a rational function. We've got a numerator and a denominator, a quotient. So it says to do a table and a graph. Why don't we do some values that are close to where our asymptote is going to be and some values that aren't so close. So, and I know there's going to be an asymptote at x equals 0 because 2 divided by 0 is undefined. So I'm going to pick some values that are maybe like negative 3, negative 2, negative 1. And then as I get close to 0, I'm going to do like negative 0.5, negative 0.3, negative 0.1, maybe like negative 0.001. And then let's do some values. Well, we can put 0 in there. And then let's do positive 0.001, positive 0.1, and so on. Now you use Desmos to get this. I'm just going to put this into my calculator. Let's see, table set. Let's start at, well, let's do independent ask. And then second table. Okay, so negative 3. Now look at what happens at 0. You get an error. Why is that? Oh, it's not going to let me do anything past that. Let's see. Let me fill these in. So -3, I got -0.667. -2 is -1. So you're just plugging in -3 right here. That would be -2/3. Plugging in -2 will give you a -1. Plug in -1 will give you -2. Plug in -0.5. Oh, sorry. Okay. Whoops. I'm going too fast. Okay, negative point. Oh, I didn't get that one in there. -0.001 is -2,000. Okay. 0.001. Okay, it's just going to be okay. So we have to do a graph. So I'm just going to, I don't know, I might use graph paper for this. I think I am going to use graph paper. Let me get some. Here it is. Okay. Okay, so I'm looking at this, and I know I have an asymptote at 0. I'm thinking about that. I know as it gets closer and closer to that asymptote, it's going down towards -infinity. I got a point at -3 2/3, -2, -1. So I'm kind of just mapping this out, how I'm going to fit it on the graph paper. So let's see, -3 is -2/3. -2 is -1. Not really, okay. -1 is -2. -0.5 is -4. Okay, -0.3, -6.6. -1, -20. So I'm not even going to worry about -0.1, and then -0.001, -2,000. So my points are getting closer and closer and closer to that asymptote, which is at 0, but they're never going to intersect that asymptote because at 0, the graph is undefined. So it just approaches that line, that vertical line, and it never intersects it. And then same thing coming from this direction. Let's see, let's start with 0.3, or maybe let's start with some of these integers. 2 is 1, 1 is 2, 3 is 2/3. Okay, and then you can kind of see what it's going to do. 0.5 is 4. 0.3 is 6.6. Let's not even worry about the rest. So you're going to have something that looks like this. Okay. And let's describe it. So I'm going to use all of the bullet points. They are in the second lesson, and it's after question 1-13. That's where I'm getting these from. So shape, let's see. I'm not going to worry about shape. Let's do domain and range first, because that's what is different here. The domain would be all numbers except 0. 0 is the only number where I don't get an output. So let's put x does not equal 0, and range. You have an answer for every point except for x equals 0, and y is never going to equal 0. So that's kind of a shortcut way of writing our domain and range, since those two numbers are not included. Let's do asymptotes. So this graph is not crossing the x-axis either. It's if we keep choosing points below -3 or points above +3, we're just going to get points that are just a little bit below that x-axis. So we have asymptotes of the x-axis and the y-axis. These are never crossed. The graph just gets closer and closer and closer to those lines. It's not linear. You could say that about the shape. We do have symmetry. It reflects across the line y equals -x. So if I were to draw y equals -x, that's a y-intercept of 0 and a slope of -1. It's reflected in that line. Could also say it reflects in the line y equals x. Anything else? So I'm skipping over some of these because there's no endpoints. There's no maximum or minimum. It just gets bigger. And there's no max or min. Gets bigger, goes up to positive infinity, goes down to negative infinity near that asymptote. It is continuous except for those asymptotes, so we don't even need to worry about this if it's got an asymptote. Is it a function? Each input has exactly one output, so yes, it is a function. We don't have x and y intercepts. For increasing, decreasing, remember you always read a graph from left to right. If you were walking from left to right, you would be going downhill until you got to 0. Then the graph is still decreasing over on this side, downhill. So decreasing, decreasing. But when you have an asymptote in there, you can kind of just focus on what the behavior is near the asymptote and focus on that. Okay, I need to sharpen my pencils. Okay, I'll try and pick up the pace here. The temperature of a box pizza carried on how long it has been out of the oven. Sketch a reasonable graph of this situation. Be sure to label the axes. Should your graph have an asymptote? Why or why not? So we have time and then temperature. So once that pizza comes out the oven, it's very hot. Then it starts cooling off. Is it just going to keep cooling off? Eventually it's going to hit room temperature, and it's just going to stay at room temperature, right? So, and actually you would have a y-intercept. So that means you would have an asymptote at room temperature. Okay, 144. We're just solving some equations. So I want to get x by itself. If it helps, put a 1 under x minus 1. Whoops. So x times x minus 1 equals 6. So x squared minus x equals 6. Let's bring the 6 over here, giving us 0 equals x squared minus x minus 6. And let's factor this. Okay, what can I multiply to get negative 6? But when I add it, I get negative 1. So that's going to factor into whoops, where did I get that? And using zero product property, there are my solutions. Okay, I'm going to say, well, we can do this one pretty fast. I'm trying to save some time here. I know this is getting long. 9 over x equals x. So same thing. X squared equals 9. Just easier to solve. So x could be, take the square root of both sides. X could be positive 3 or negative 3. Either one, if I square it, I get 9. For 145, if 1 is the output for Carmichael's function machine, drawn it right, how can you determine what number is dropped in? This is kind of like the one we did earlier. We may just wind up skipping. Let's just skip 145. Don't worry about it. Let's just shorten 146. It's saying to find the y-intercept and write the answer as an ordered pair. So I think solving these would be relatively easy, but do you know how to solve them? If you're finding the y-intercept, what would you substitute for x or y? So let's just write how you would do these. So 146, to find the y-intercept, think about where the y-intercept is. It's on the y-axis. Any point on that y-axis is going to have an x coordinate of 0. So you're going to substitute 0 for x. And let's not worry about actually doing that. And I might just say, let's not worry about 147. It's asking us to solve 4 quadratics. I do kind of want us to do 148 because it's the slope of perpendicular lines. I find that people often need a review on that. Okay, so it says graph y equals 3x plus 3. Sketch the line that's perpendicular to y equals 3x plus 3 that passes through this point. It's a very common standardized test question, and write the equation of that line. Let's do that one, and then we'll call it a day. Let's see, I'm going to come down. Actually, 3x plus 3. That's a pretty steep slope. I'm just going to do this on the back of my graph paper. Okay, so y-intercept is 3, slope is 3, so up 3 over 1, beginning at 3, and then down 3 over 1, going backwards. that's y equals 3x plus 3. And we're going to sketch the line that's perpendicular to that goes through negative 3, 2. Okay, remember that slopes, let's write this, slopes of perpendicular lines are, do you remember? Think about it. Let's see, it's going through negative 3, positive 2. It's going through this point. It's perpendicular, which means it intersects this at a right angle. So you can almost see what that slope is going to be. It's going to be, instead of up 3 over 1, can you see it? Down 1 over 3. It's kind of hard to tell because they don't intersect right at one of these points. So slopes of perpendicular lines are opposite. One's positive, the other one has to be negative if they're meeting at a right angle, opposite reciprocals. So I know it's going through this point, negative 3, 2. So that means I know the slope, let's put slope is going to be, instead of up 3 over 1, down 1 over 3. And I know it's going through this point. So let's just start here and go down 1 over 3, down 1 over 3, and maybe go backwards, up 1, left 3, and there we have our perpendicular line. Okay, that was a lot. I'll think twice about assigning that many, but I just saw a lot of good problems there, and you only have one homework assignment this week other than the discussion. So, oh, we have to write the equation of that line. So that equation would be y equals, oh, getting the y-intercept, huh? No, it's right here. Okay, nice. 0, 1, so y equals negative 1/3 x plus 1.